All right, so there was a question on what's going wrong in these two problems. So for number 10 here in 2.1, we see that the derivative was taken correctly here. So you've got the derivative function, and all this looks good when you make a substitution for f prime of 3, but it looks like this one got raised to the third power instead of the sixth power, so that's why I think this was off by a bit. And again, you can plug in this into Desmos and take f prime of 3, and you'll get what you should have, and so that might clue you into, all right, something happened right here. But for this one, the problem is actually a little bit more of an issue, and how it happened is right here. So writing it like this and not rewriting it into a more workable form, which I'll show you in a second, is means that you're going to have to use the product rule, because you've got a product of x to the fifth times x to the 1/2, right? And so the fact that these derivatives were taken just right next to each other breaks the product rule, which again requires us, when we have products of functions, to do f prime g plus f g prime. Right, it's kind of that corner of that area of that rectangle, if you remember that graphic from the product rule section. So for this, what I would do is, instead of using the product rule, is there a way to write this using power functions instead of keeping them split? Can you rewrite this as, well, this is x to the fifth, right? Or fifth over 1. That's a 5 times x to the 1/2. And what's one way to write this as a single function? Well, if we have x to a power times x to another power, it's really the sum of those powers. This is x to the 5 plus a half, right? So if 5 is really 10 halves, then we could write this as x to the 11 halves, right? Because if this is 5 over 1, this is really 10 over 2. And so we're left with this. And now this is just a power function where I don't need to deal with the product rule anymore. And then I can differentiate. And so what I'll get, 11 halves x to the 9 halves. And so that's obviously very different than what you have here. And it's just because of that distinction. So this is a big part of calculus, is just rewriting it into a more workable form so we can dodge using complicated formulas or just simplify the problem. And so the same thing happened here as well. So I just encourage you to rewrite these as power functions whenever you can, because the power rule is like the simplest one that we have.